All right, I guess it's about that time. Welcome everybody to this session on data modeling in Excel using Power Pivot. I'm Howie Dickerman. I'm a program manager on the Excel product team. And I'm going to go ahead and try to start here on time because we got a lot of material to cover and not very long in which to do it. Okay, so the agenda for today, we're going to cover really 5 topics. And it's interesting. We're going to start out with some very basic stuff, and the pace will pick up as we go along. But really, we're going to talk here about the fact that in Power Pivot, how it differs from regular pivot tables and the ability to handle multiple tables and relationships. We're going to talk about importing editable data from the Excel worksheet into the Power Pivot data model. I'm going to talk some about the DAX expression language, DAX formula language, and how that's set up. I've got a specific example of a custom calendar. I'll talk a little bit about custom calendars and why you want to use them and how you can do that. And then really get into this thing called measures. And measures are really important, and it's the one concept that people who are very familiar with Excel will find sort of new to them as they build their data models. But it's a very important concept. I want to make sure you understand it a bit. The first topic is really just to say that we have now a data model in Excel. We refer to it as the Excel data model. This data model is basically a database. It's a relational database that's stored inside the workbook. The editor for that database, the tool that you use to add tables, to add relationships, to add calculated columns, and so on, the editor is Power Pivot. This database is the same kind of database used in other Microsoft products. So we use an in-memory column-based storage mechanism. The reason that's interesting is because doing things in memory makes it really fast to run queries against it. But this is the same database engine. This data model uses the same engine that's used in Power BI Desktop, and PowerBI.com. It's the same database engine used in Analysis Services, which is a technology that ships as part of the SQL Server product. So if you're familiar with Analysis Services, if you're familiar with how to do data modeling on any of these, you already know how to do it in the others. And this data model contains basically tables of data, relationships between the tables, and various calculations. This enables some new things that you can do in Excel pivot tables that you couldn't do before. Traditional pivot tables before the data model required you to have a single large flattened table. How many of you used to have a table of data and then another table somewhere else, and you use VLOOKUPs to bring that data from the other table over? Okay. We eliminate the need to do all those VLOOKUPs and to bring those columns over, because traditional pivot tables, the field list is just a single set of fields for a single table. Here, as you're going to see in a moment, we have multiple tables, and the field list is a little bit more complicated. It's no longer necessary to copy that data over. If I have 1 million transactions and you refer to 100 products, I don't have to copy the 100 rows of information into all 1 million of those transactions, duplicating it everywhere and leaving myself open to problems when I get something spelled a little bit differently or mistyped or whatever. And we also don't need to worry about all of those VLOOKUPs that I have to make sure stay accurate as I continue to enhance and maintain the workbook. Okay, so what we'll do is go now to my demo. So first, let me show you that we have the Excel window, and then we have Power Pivot. Power Pivot does come up in its own window. You'll see here I have a second window. I have Excel and the Power Pivot window. But it is running as one program. Excel and Power Pivot are running inside the Excel process as a single process. In that Power Pivot window, I have one option is to be in what we call diagram view. And in this particular diagram, by the way, for my examples today, I made some very, very simple tables without a lot of data. Very straightforward. I have sales transactions, and there are only 50 of them. You'll see them in a moment. I think it's 5 products and 5 customers. Just very, very simple. This line shows a relationship between the sales transaction and the customer table, and when I select the line, you'll see that it highlights that the customer ID in each table is the way that those are related. Similarly, if I highlight the relationship between sales and product, it's the product ID, and the date of the sales transaction is hooked up to my calendar. So these are 4 tables related together, very, very simple relational database. I can switch between diagram view to data view. And here, the tables, I see are the rows of data for each table. You'll see here are my sales transactions. This is my customer table. It's probably very simple. 5 customers, 5 products, and a calendar table we're going to talk about in more detail in just a little bit. What I'm going to do here, if I go to the sales table, you'll see that in this window, you'll notice the pane is split. I have a line here that I can pull down. These are the columns of data that were brought in from the original data source. The data source, in this particular example, my data came from the Excel sheet. So if I go back to my Excel workbook and go to my data tab, you'll see here are my 50 transactions, my 5 customers, my 5 products. I brought the data over from here into my Power Pivot window. The columns with the green headers are the ones that came in. Then I have calculated columns. Here's an amount column. And I have another calculated column, which is discount per unit. And then down below here, I have some measures. The items below the line are what we call measure formulas. And you'll see here that transactions is a formula, count rows of sales. And that value that it's showing me right now of 50 will change if I come in here and filter the data to only show a couple of the customers. We'll see that number will change. Okay, so that's just the super high-level view of what the Power Pivot window looks like. Okay. Now, what I'd like to show you is if I go to the Excel window and I go to one of my pivot tables, here's a pivot table. Here's my field list. I just want to point out, as I mentioned earlier, now I list a bunch of different tables here in the field list. And if I expand this, I'll see the individual fields that are in there, and I can use those. And so it looks a lot like traditional field lists, but I have this ability to now point at a relational database and not just be pointing at a single table. Okay, and we're going to come back to here in just a moment. So let's go back to the slides. Importing data from the worksheet. So the data model is effectively, think of it as a read-only copy of the source data. The source data can come in from anywhere. I can bring data in from any number of sources. I could bring it in from SQL Server, from Oracle, from web services, all kinds of data sources, and I bring that data over into the data model. When I bring data from the worksheet, now on the worksheet, of course, my data is completely editable, so I can bring these tables across, and then with the data in the model gets updated whenever I do a refresh on that connection. So you can think of it as I have a query that brings the data into the model. I can refresh that whenever I want. And I can use, when I want the table to be editable, I can put an editable table on the Excel workbook, in the Excel workbook on one of the worksheets, edit it there to my heart's content, and then refresh it over in the data model. And there are some places where that can be particularly useful. We also, so I will show you that we have this ability to add tables directly into the model in a bunch of different ways. And I'm going to just show a couple of those. But there are different import tools and query tools. One of them is known in Excel 2013 as something called Power Query. In 2016, we integrated that natively into Excel. And so we have this notion of get and transform. I'm going to show you some of that. We also have something called Add to Data Model button that creates something called link tables. So there are a bunch of different ways to do it, and I'm going to show you a couple of those. Let's go ahead and do that. Okay. So 1 second here. So first of all, I have here on a worksheet, I've just got some 10 transaction rows here in a small table just to illustrate this. The name of the table is called Test 1, and I can click in here and say, go to the Power Pivot ribbon and say that I'd like to add this because I've clicked anywhere in the table. I can go in and say I want to add this table to the data model. So I'll press that button. I left it in the middle of an action here. I'm going to just go to the other window. Get out of that. Okay. I'm going to, sorry. We'll get this here one second. Okay. And what it's doing is it brings up this window and it adds test 1 to the data model. But what I'd like to show you is that I can now go back to my source, edit this data. Let's say that I want to come in here and change the quantity on this first row to be 555. I'm going to change the next one to be 333. I'm going to add a 12th row to the table. And just add some more fields here. Oh, hit the wrong key. Okay. And now, when I go back and set the focus back into Power Pivot, in this case, because it's a linked table, you'll see that it changed the quantities in those first 2 rows and the 12th row. So this is one technique for automatically updating data that I bring over from the sheet as a linked table. A different technique that I can do something that seems a little bit more complicated, but it's also way more powerful. And that is to use the new get and transform capabilities. So here I have some data. I'm going to scroll over to get the whole table on the screen. Here I have some data in a format that's already sort of pivoted. I've got headers both on the left and the right. I've got some sales figures for by fiscal year and by month. And what I'm going to do is go to the data ribbon, and you will see here a new chunk. This is in 2016. It's called Get and Transform. And the items that are in this section of the data menu are available in Excel 2013 as a Power Query add-in. So if you install the Power Query add-in, which is a free download from the web, you will then have another ribbon that has these same commands on it. And I could say that I want to import from the table. I want to query from this table. And this brings up what we think of as this query editor. And just to show you the kinds of, now this obviously is more complex than just pressing a button that says add to data model. But the kinds of things I can do, for example, in this instance, I'm going to select the data for all of the months. I'm going to, let's see, I'll scroll here and shift select. There, I've got the 12 months. I'm going to go up here into the transform ribbon, and I'm going to say I'd like to unpivot those 12 columns. And that changed the data. So although the source data had the format that it has on the worksheet, with the way the data is going to land is like this unpivoted. And the other thing I'd like to do now is to select just this value column, go back to my home ribbon, and say that I want the data type here to be currency. And I am going to load this, close that editor, create a connection, and add this to the data model. And what happens here is I have a query pane that opens up on the right, and it runs this query, and it put these rows into the model. If I go to my Power Pivot model, you will see that I now have a table here called Test 2. It has this data in it, and this is set up for me to do additional pivoting or whatever I may want to do on it. To show the refresh technique for this, again, is slightly different. I can come in here, and let's change this first number to be 111, and the next one to be 222. And now that I've done that, I can come in here, and I could right-click and refresh from here, or I could go to the model and refresh from there. It will rerun that query and re-update it, and so now when I come back, you'll see the values have changed. So this is just a couple of different ways of putting editable worksheet data into the model. Of course, then we also have the ability to bring all kinds of data in from a variety of other data sources. Okay, let's go back to the deck. And all right. And I'll talk a bit about the DAX formulas here. So DAX formula language is an expression language we designed to have exactly the same syntax as Excel. So when you see me we're going to look at a bunch of DAX formulas here in a moment. And when we do, you'll see that it looks an awful lot like Excel. Some of the functions are the same as in Excel. We started out with about 80 functions that are in Excel that are also in the DAX language, and they're identical. But then we added a bunch of other functions to provide additional kinds of capability. Today, this session is obviously not a course on DAX. A course on DAX would take way more time. There are some courses on DAX in some other sessions, and even the multiple hours they've allocated isn't really enough. But there's tons of stuff to learn there. But to offer some examples, for example, we can have a function that will follow a relationship and pluck a value out of another table, out of a related table. So if I want to create a calculated column in my transaction table, the sort of thing that you would do a VLOOKUP for, where I want to go get a related value from a related table, we have functions to do that. One of the interesting additions is we have functions that will return entire tables of values. So unlike Excel functions, which always return a scalar because they go in a cell, and in a cell you always have to have a single value, we can have functions that will return tables of values, and then we have other functions which use those tables as arguments to them. So I can, for example, scan over a table of values and calculate the sum or the average or the standard deviation of some expression that's being evaluated for each row in the table. We have these formulas are used in 3 different places, really, within the data model. We use DAX for calculated columns. We use DAX for measures. And we also can use DAX as a query language. It's possible in Excel to create a query table, for example, and have a DAX expression that defines what will come back and what will populate that query table. So it's really used in those 3 places. Let's take a look. And I am going to go now to my Power Pivot window. We'll start out in the sales table. So here's my first example, is that I got an amount column, which is a calculated formula. And the calculation is, I don't know if you can see if that's a little small. I can try to zoom in on the formula here a little bit. Price times quantity times 1 minus the discount percent. It's just a formula that I put in here to calculate that. This looks a lot like what you would do in Excel. We can refer to columns in Excel tables the same way we use square bracket notation to indicate that we have a column. It's very much how you would do that in Excel, but in this case, it's actually a DAX formula. We also have, for example, this discount per unit, which is the discount percent times the price, and these are just the names of the columns. If we look at the products table, you'll see, now this is an example I talked about where we use a function that returns a table and then use another function on top of that. So you're all familiar with it. We have a sum function in both DAX and in Excel that will sum up the numbers in a column. We've created SumX. We also have MinX, MaxX, AverageX, and so on. SumX says sum an expression over a table. The first argument is a table. The second argument is an expression. We evaluate that expression for each row of the table, and then in the case of SumX, we add them up. If it were AverageX, we take the average. So in this particular case, I'm in a product table, and I've said, I've got a function in here called related table of sale. The first argument to my SumX is related table of sales. Since I am in the row for a particular product, it says, go like a VLOOKUP, but not quite. It says, go to the sales table, get me all of the related rows, and return that table to me. So it says, go get me all of the sales transactions for this product, and then add up the sales amount. The syntax we're using here, sales amount, this is the name of the table in front of the name of the column, so I get a fully qualified column. You can easily imagine having a column name that exists in multiple tables. I could have a column named ID, and it's in every table, has a column named ID. I want to say which one. So in this case, I'm saying, get me the amount column from the sales table. So that's what's being done there. We're going to come back to this in a moment. This is a calculated column that does some ranking, and it seems okay on the face of it. I'm sort of ranking for each product what their sales rank is, but there's a reason that we'll get to in a bit why you don't want to do that as a calculated column. And then let's go look at some simple measures here. So I'm going to, I guess, scroll. Oh, sorry. 1 second. I am going to. Okay. I'm going to just want to get back to that window here, and I'm going to just reclose this. Sorry. Not supposed to be doing that. All right. I'll just close it. Just going to close it and restart it. Not a problem. Okay. I think, did we come back up? Sorry about that. That's what I get for I installed daily builds on this machine. That's the price I pay. All right. So we'll go back up in here, and now we have these measures. This is what I wanted to show, are the measures on the, which are in the bottom part of this grid in the Power Pivot window. So transactions, these are named formulas, and the way you want to think about measures is a measure is a formula that does not have just a single value. It has many, many values. These measures will wind up going into a pivot table, and if the pivot table happens to be 50 rows by 10 columns across, I'm going to get 500 different results for the same measure. So the measure is evaluated in some context. A measure gets a value. Now, in this particular grid, we're showing the value of the measure for the entire data set. But if the measure is written correctly, the measure really should be applicable so that it can give me a result if I have half the data, 10% of the data, 1 row of the data. I want to be able to slice the data set, filter it down to a particular product, to a particular month, to a particular customer, and have it still come up with a valid result. So think of these as a named formula whose results will be evaluated dynamically on the fly. Sales here is, for example, the sum of the sales amount column. So it's just the sales of the sum amount column here. And we get a value for that for the entire data set. And you can see that I can get different values again if I slice this thing down. If I filter it for a particular subset of the customers, I get a different value. If I, if I want to see it for certain and only for certain products, I can filter it down some more, and we'll get different values for it. But these down here, transactions, sales, are measures. When we get back to more measures, we're gonna talk some more about these other ones. All right, so let's go back to the deck. And all right, what I'm going to do now is talk a little bit about custom calendars. When you're building these models, first let me say that there are a bunch of formulas available in DAX, a bunch of functions that do what we call time intelligence. I can do things like give me the parallel period going back, so many days or so many months, or go back 1 year, go back 2 years. I can go ahead 90 days. I can shift things around. We have a lot of functions that provide time intelligence capabilities. For all of those functions, though, we do want you to have in the model a table, which you can call, I happen to use the term calendar. Some people like to call this a date table. Some call it a time table. Some people who've done multidimensional modeling will refer to these as time dimensions. There are any number of things. The calendar is something you want sort of regardless. Now, there are ways in these tools to just sort of automatically generate calendars. If what you want is a very straightforward thing, your year is based on a calendar year, your fiscal year ends on December 31st, you use regular months, you can just create a sort of automatic calendars. We have some stuff in the product that'll do that for you, make it very, very simple. But there are many companies out there who have fiscal years that don't end on December 31st. There are many industries out there where they like to do their accounting differently, where they want to be able to break their sales data up, whether it be 4-4-5 calendars or 4-5-4, or people have 13 4-week periods, or 12 months of 30 days each, and I could go on and on. And many people want to do special things. They want to flag, this day was a holiday, or this day we gave everybody the day off. We closed down the place for a couple of days for some other reason that only we know. We want to be able to mark that in the calendar, because when we're looking at our sales figure and doing our analysis, I want to be able to do math that divides it by the number of days the store was open, or that the business was open, or things of that nature. And so I've built a simple custom calendar that we'll go take a look at here. In this particular calendar, actually, let me just go and show you on the Excel worksheet. Here's the calendar. I went in and I said, let me start at January 1 of 2015. And once you fill in 2 or 3 values, I then just dragged it down and dragged it down to I ran it till July 1st of 2017. That's the size of my table. I said things that I might want to use in my pivot tables include the day of the week if I want to do analysis. And my point here really is that you don't need to do what I did here. My point is that you can do anything. Because I'm doing this in the Excel grid where it's fully editable, I can use formulas to calculate these columns. I can type them in by hand. I've done some of both. I said, let me calculate a week number based on a fiscal year. I'm saying my fiscal year is going to end roughly June 30, but instead of aligning it on the month end exactly, I'm actually going to construct specific weeks and have my fiscal year end at the end of a week. And so in my particular custom calendar, the year does not, and I'll page down here and show you. In this particular calendar, the fiscal year changed here on July 5th, because that's after week 52 happened to end on July 4th. And so my fiscal year switched here. I'm using some Excel formulas to generate this. I've figured out what is the quarter. I've decided that in my calendar, I care deeply that I have exactly 13 weeks in every quarter. That's the way I'm doing this thing. I've calculated the month and quarter. I've got a fiscal month that I can use. And all of these field columns will then be available to me in my field list when I go to have my pivot table to slice my data. And here's one that I did not do using a formula, where I just typed the values in. I created a column which I called comment, and I went in there and I marked holidays, and I marked I did some stuff to mark the weekends, to mark the holidays, and I could go in and mark this in any custom way I want. I could have as many columns as I want. I then brought this table over. And to my model, and I'm going to show you. I created a couple of measures for it. So if I go to my count, so here's a measure. One measure is called days, and I defined it as count the rows in the calendar table. That's all it is. If in my pivot table I happen to slice this down for a particular year or a month or a week or whatever, that'll filter my table, and I'll count the rows in the table. That's how I know how many days there were. Days open, I defined using a DAX formula that says filter, and this is count the rows of something more common. So count the rows. By the way, can folks read this okay, or should I zoom in? I see some. Let me do the zoom just in case. Okay. So I said filter the calendar where the comment field is blank. Right? I said is blank of the comment field, and then count the rows of what's left. And so that's the way that I measure the number of days open. Similarly, for count the rows of filter the calendar table with a comment equals the word holiday. That's how I get the number of holidays. And I did something very similar for weekends. And just to show you, so then when I go to when I create a pivot table in which, and I'll move this field list out to the side. I've got a couple of pivot tables here. So you can see that in my pivot table, in this particular pivot table, I've put fiscal year and quarter and so forth on the row labels. I've put my measures across here. So these are the number of days in my calendar. You remember that my data, I only started at January 1 of 2015, so I'm showing 185 days for 2015. But for 2016, and because I'm always exactly 4 quarters of 13 weeks each, I've got 364 days. I have 250 days open. If I expand this down and break it down by quarter or by month, I get the precise counts. I know how many days were weekends. I can use this data to create measures around my sales figures. So if I want to know my average sales for a day, I don't want to just know per calendar day. I may want the average sales per day open, or I may want, or something else that I want to do. If I go in even further, underneath one of these months, you'll see that I get. And here I've defined, because my fiscal year starts in July, you'll notice that my fiscal month 2, when I open it up, it starts on August 2nd. That's just where that happened to fall. This is entirely a custom calendar, not based on the one that's hanging on the wall at my house that I get several of in the mail every year, right? So that's basically, similarly, here's a sales thing. What I've done here on this sales pivot table is I've said, well, let me just put fiscal year across the top, and let me put quarter and month down here. And here I'm just using, I have a single measure here, a single sales measure, which we define as the sum of the amount column. That's all it was. It does not have one value. It has a whole bunch. In this instance, actually, I don't want to grab the headers. The area that I've selected right now, there are 29 cells. So that measure in this instance is giving me 29 different results. This is an important concept. This is one of the sort of the concepts that I'd love for you to learn about Power Pivot. You need to understand how measures work. I'm getting a different result in each concept. The result for Q1, month 1 in fiscal year 2015 is a blank. That's the result. It comes up blank. The result in the context of fiscal year 2016 for the grand total, for including all quarters and all months, has a result. So each one of these cells represents a context, because as you go to try to read the books on DAX and read the books on Power Pivot, everybody will talk about evaluating measures in a context and how to change the context, and you'll see that in a bit. Our next topic is going to be measures, and I'm going to show you more of that. So this is where the measures are going. And again, I can slice and dice this any way I want, putting fields. I have all the normal Power of Pivot tables with all of their capabilities, but I'm working against a database of multiple tables. Okay. By the way, because in this instance, my months were actually, I didn't point it out, I should have, these were 4-4, I set them up as a 4-4-5 months. So just to go back, I'll call your attention to the fact that here, you'll notice that I have 28 days in month 1 and month 2. Month 3 is 35 days. Similarly, month 4 and 5 are 28. Month 6 is 35. So I did a 4-4-5 thing here, and I just did that because that's the way I set up the table. And then the holidays falling wherever they are, I see here, gee, we're only open 17 days in month 5. I wonder why. Turns out that's November. It turns out Thanksgiving has a lot to do with that. Okay? So that's okay. So now let's talk about measures. And this is really the meat of what we want to talk about. We'll go back to the slides. Great. I'll get slides caught up. Here we go. Okay. So I've mentioned that the measures are named formulas, that they're evaluated for that a good measure can be evaluated for any slice of the data. And it should work when there are no rows, when there's one row, when there's half the data, and so on. Well-written measures are usually a simple aggregation of the data. That is, it's a sum of a bunch of values, or it's the average of a bunch of values, or it's the minimum, or it's the maximum, or it's the distinct count, or it can be a combination of simple aggregations. It can be a ratio. I can say it's the sum of this divided by the sum of that, or it's this measure minus another measure. You want them to be simple like that, because if they are simple like that, then they will work for any subset of the data. Many times people try to get very fancy in the measure. They start writing a lot of custom if statements, and but if it's in this and they do all kinds of fancy calculations, assuming, and the picture in their head is, they assume that this measure is going to be used in a report where there are certain things down the left-hand side and certain other things across the top. They assume that there will be dates. They assume that there will be countries or regions or stores or employees. But the problem is that some measures written like that start behaving badly when you try to drag them into a report that doesn't look that way. If the formula requires that there be a month and you use it in a report where the calendar is not involved, in a pivot table report without those fields, you can get funny results. So measures in general should be, the point I want to make is that they should be simple, and that it does simultaneously, effectively, conceptually, it gives you multiple results simultaneously. I drag a single measure into that pivot table, and I get all the results for all of the different cells with all of the different contexts. These are much more powerful than calculated columns. There is a huge tendency when people are new to Power Pivot, the thing that they always want to do is create calculated columns for everything. Because it makes sense, it's what they're familiar with, it's what they've done in Excel forever. So you have a table of data. I want to do the rank. I know I'll get the rank, or I want to do, let me just create a calculated column and get the values there, and I can look at them and examine them and debug it, make sure it's right, and then I'll just go to my pivot table and I'll use that column in my pivot table. That won't really work. It won't get you what you want for two reasons. One, the calcs will actually wind up being wrong, but secondly, the calculated columns are calculated when the data is refreshed, and the values are entirely static. So calculated column is correct and perfect if the value in that calculated column depends only on that row. So if I want to multiply the price times the quantity to get an extended amount, that's perfect. Nothing wrong with that. That number will never change. 4 widgets at $10 each is going to be $40, and nothing changes there. That's great. But things like ratios don't add. Things like rankings don't really work as calculated columns, and I'd like to show you some of that in just a moment. Let's just go ahead and do that. So for the measures, the first thing I'm going to do is let's go to the model, and we'll go to the products table. And in here, there's a formula in the calculated column that says, using our rank X function. You've seen that X notion before. I was showing it to you before. It says, take a table, in this case the products table, and then rank what you've got here based on product, evaluate product sales for each row of the table and give it a rank. And by default, it's in descending order and so forth. And you might look at this and say, hey, this seems right? I've got 1 for product 3 is first, and product 4 is next, because I can see the total sales figures, and this all seems to make sense. This seems correct, but it won't. So, for example, if I come in here and I say I only want to rank the items that have weights over 25, and I get rid of the other items, it's not. This case, it's really not the thing that I want to get. Here I have a product rank formula, which is a little bit more complicated, and you'll see why in a moment. I did something. This is a construct that you'll see sometimes in measures. I wrote this out on multiple lines. By the way, if you're in this, if you want to get to a new line in this editor, Alt-Enter will get you to the new line, very much like in Excel. What I said here is I used an if statement. I said if there is only one product involved, if I have a single product, so if has one value of product's product ID, if there's only one product, then use this formula, which is a rank X, another version of rank X, to give me a rank based on sales. Otherwise, else return blank. The reason I want this, and you'll see this in a pivot table in a moment, is that in my pivot table, not only do I, if I put products there, then I'll get a value that makes sense where I have a product. If I don't put products there, or if I'm in the totals row, I don't want the totals, that grand total doesn't make sense for that to be ranked. So if I'm going to rank here, this is a product rank. It only makes sense in a context where there is only one product. And so that's why I use this formula. So if I go out to the, I'll go out to the Excel window, go to my, I'm going to scroll over. and up. Here is where I use that measure. I'll just point out here that I have a pivot table where I put the products down the left, and I've got the sales figure, and I wanted to rank it. And that all seems good. The reason I want this to be a measure, and the reason I don't want to use the number that was in the calculated column, is sort of illustrated really well. Let's add fiscal year to this. So let me go into my calendar table and take my fiscal year field and add it to the rows. So now I've sliced again by fiscal year. And in fiscal year 2015, rank 1 is product 3. In fiscal year 2016, it's a different product. In fiscal year 2017, what I'm getting at is that these numbers are all different. Product 1 is second in this year, and it's fourth in this year, and it's third in this year. My point is that by using a measure that gets evaluated dynamically when it is used in the pivot table, and the number is reevaluated when I slice, when I add another slicer, when I add a filter, when I move things around, it's evaluated. That's what you want for something like this. A calculated column would not have that behavior. In that calculated column, the value would be completely static, and it would not change. So that's the illustration of that. In the sales table, if I look here, here is, let me go back and do the measure thing. When I took the discount per unit, I should look at the raw data first. In my sales table, here I have discount per unit. This is the discount percent times the price, and it comes up with a dollar value. But if I use this column anywhere, it's just going to add them up. You know, in pivot tables, when you drag a numeric field into the values area, it just adds them up. If you drag a text field, it counts them. And that's what pivot tables do. What I need instead is I need a measure like this one, per unit discount. This says, give me the sum of this is one sum divided by another sum. So it's give me the price times the quantity times the discount percent. That is, sum up all of the discounts divided by the sum of all of the quantities. And that'll give me the discount. That ratio that I've defined here will work for one transaction, for 20 transactions, or for all the transactions. And that's really what I want. And the illustration of this is in that pivot table, where using my measure, I get numbers that actually work and make sense for this data set, and my grand total is valid, and so on. Here, the sum of the discount per unit, it just went and added up a bunch of numbers that, it's really not what I wanted at all. Okay? And so this is another example of not wanting to use the calculated column. So now, let's look at another measure that I think really illustrates things pretty well. I've actually got 4 pivot tables to show you. I'm going to scroll to the resolution here. I've got to scroll a little bit. The top pivot, let me just say that I have here 4 pivot tables. The first, they're identical except for they each have one measure, and the measure is different in each case. The first one is just showing me the sales dollar amount. It's sum of sales amount. Sales, this is the formula I'm showing you on the right. And what I've done is I've sliced it. I've said, let me put the customer name down the left and the product color across the top. And let's just find out what are the intersections. What did Howie buy? I could tell how many dollars of sales did Howie buy of red products, of white products, of yellow products, right? Very interesting. Now, let's say that a very common thing that people want to do is they say, I want to get percent of parent. I want to know what is that as a percentage of the total. And my question for you is, which total? Because there are different ways to look at that. And so I'm just showing you, we can actually, in our measure, we can construct measures, and I've created 3 measures here called the percent of percent all customer, percent all product, and percent all sales is how I think of them. And these are just the ratios of some calculations. In this top case, I said, I want to know what were my sales as a percentage of all of my sales for that customer. In which case, so looking at the sales numbers up here, so I've got 100% for all the customers here, and my sales of red was 50% of that number. In this instance, you get sort of 100% along the bottom, right? The other instance, you get the 100% down the right. And in the third instance, everything is as a percentage of the grand total in the bottom corner. And the way that this works is that what I've done here is I've said, give me the sales. This formula says, give me the sales in the current context divided by sales in a different context. And what I'm doing is I'm changing the context, changing the coordinates, if you will, of the cell for that part of the calculation. Here I'm saying, take the sales for the current cell, whatever it is, whatever combination of product and month and whatever it may be. But with the numerator and the denominator on the bottom, I want to change the customer selection from whatever the current context says to be all customers. So in that instance, I'm saying here, give me the sales for red products for Howie on the top divided by the sales of red products for all the customers. And that measure gave me a whole bunch of different results gave me, in this case, 26 different results in 26 different cells. Similarly, this is the sales for me divided by the sales for the current context divided by the sales of all the products. So if I want to know, this is the sales for the current context. Here's the sales of Diana, but 22% black, 67% green, 10% red adds up to 100% in total because that's for that total. On the bottom one, with the context, I said go to divide by the sales for all the sales. This is use the grand total for all the sales regardless, sort of wipe out all of those filters. Now, of course, it's very easy to get into way more complex examples of this. But the point I want to make is that you can create a measure that does just about anything. It will be evaluated on the fly, dynamically, and you can change the think of this as something that's going to be evaluated in a pivot table, in a particular context. If I've got countries down the left and years across the top, it'll be for a particular country and for a particular year. But I can compare that I could say, show that as a ratio of what happened in 1985 in the United Kingdom. Or show me that relative to, or subtract, take the sales in this context, and I want, as a baseline, my baseline is the year 1975 for the United States. I can say subtract the same sales calculation, but for a particular year, for a particular country, for a particular product, for a particular whatever. You can tweak the context of the calculation as part of the formula. Measure formulas are incredibly powerful. They're incredibly useful. There's there's a learning curve. There's some of these formulas are very, very simple. They can also get fairly complicated, which is why there are some of our experts out there writing books on the subject. But so that's what I wanted to show you with that. Now, so let's go back to the slides. And so again, just on this measures point, again, I've said this, but just to review, it's on this, calculated column values are static. It's great to use a calculated column when the values depends only on things in the same row, but don't use it when slicing or filtering would change the results. Measures are always dynamic, and certain kinds of calculations just require measures. Things that are non-additive aggregations, things like ratios and percentages. If you have a bunch of numbers that are a bunch of percentages, the grand total row, they don't add. You want to recalculate that ratio. Okay, the wrong thing. We did that demo. One sec. Okay, so I'm supposed to do 48 minutes into a 50-minute presentation. The good news is we're about done. We managed to make this one fit. So the 5 things that we talked about today were multiple tables and relationship. The fact that we have a database in Power Pivot that has many tables and relationships between the tables. We can import editable worksheet data. We can, of course, always import data from elsewhere, although I didn't show that. The language we use in Power Pivot is this language called DAX. It looks a lot like Excel, but there are some new functions and some new capabilities. You can indeed build custom calendars, and you should always in your model have, if you're going to do anything based on time, you should have one calendar table with one entry for every day. You really want that for a bunch of reasons. And this notion of measures. And really, if you only remember one thing, this is the point that I'd like you to take away. Calculated columns are easy, they're intuitive, everybody wants to use them, But really, if you want to do dynamic analysis, measures is what you want to use. If that's the thing that you remember and take back with you, I'll feel really good about this session having done its job. With that, there are some slides that some of you may have seen that are being shown in a number of presentations. I'll zip through these very quickly. First of all, people sort of frequently ask, so there's Excel and there's Power BI, and how do they relate and what's going on? Well, we have, Excel is really good interactive ad hoc analysis. I've got to tell you, there's so much that's similar between these things. Power BI is this dashboarding tool with building big dashboards, drag and drop. It's up powerbi.com. It's in the cloud. Power BI desktop is a desktop app where you can build these models and deploy them in the cloud. Both Excel Power Pivot and Power BI Desktop and powerbi.com, we are all using the same underlying data engine. It is the same engine that's used in analysis services. They are tabular models. It's the same. The DAX language is the same. The measures are the same. Really, so the whole notion here is that if you're familiar with how to do stuff in one, you can almost instantly go do it in the other. It may be that the window's a little different, the menu may be a little different, but conceptually, these data models are the same. Some of the graphic visualizations are a little bit different. Excel charts are Excel charts. The Power BI visualizations in the service are a bit different, but there are some huge similarities here, particularly around the data modeling. And the share for the data import tool, the piece, not the one where it's the add to data model button, but the other one I showed you where we had 12 months of data and I did the unpivot. That thing, which is known as Power Query in Excel 2013, it's been integrated directly into Excel as Get and Transform, is also in Power BI Desktop. It's core to this experience. We can connect to all kinds of data. We can shape, transform, clean, do all kinds of stuff with that data. Join data from multiple sources. It's a very, very powerful tool, and it's built into both Excel and Power BI. Please, if you have, as you play with these products, if you have wishes for things you'd like to see us add later, you'd like us to add a feature, you'd like us to do whatever, please go to Excel User Voice. It's excel.uservoice.com and enter your request. People will vote them up. I can tell you that somebody enters something in excel.uservoice.com, and the community of people out there voted up. We got 3,000 people all telling us they want that same thing. It really does move up on the priority list, and we do really get to it sooner. So this is the way that we collect your feedback. It's very, very important. I also want to call your attention to the fact that there is a course on these technologies, an online course at edX.com. Danny Hodder, who's a program manager at Microsoft, has built this set of course. It's been very well received. A lot of people are taking it. There's a new session starting, I believe, April 1, and so I call your attention to that. I believe everybody here at the conference is going to get all of these slides. And by the way, in addition to everybody getting all of these slide decks, there's also some supporting materials. I did upload my Excel workbook and my demo script in the supporting files. So you'll have not only the slides, but also the workbook and the demo script. And then I have a couple slides, just the schedule. I won't, well, you guys have the schedule. You navigated your way to here, so I'm not going to type your time with that. And I'm happy to take some questions. They may need to reuse the room pretty quickly. I will also be down at Ask the Experts for much of the rest of today and for a lot of tomorrow, and I am helping in one other lab. You can also send questions offline to me directly. This slide has my email address in it. I'm happy to hear from you. I'll apologize in advance. Sometimes I can respond to emails really, really quickly, and sometimes not because I'm tied up at a conference like this doing other things. But I'm happy to take questions. So that's my presentation. I think if there are some questions here, any? Yeah.